All right. Good afternoon. How is everybody? Are there any questions? Okay, today we are going to do optimization using linear programming in Excel. So please open a Word document for instructions and then open Excel file for the data. After you open the Excel file, please save the file in this PC under Document folder. The file name is original file name followed by your name. So I click Enable Editing and then click File Save As this PC and then Document. The file name for me, Lab 6, Optimization Data, and then Pauline Fu. There are 4 questions in the first question, 4 parts. So we have 4 different worksheets here on the bottom. The first part asks you to set up linear model and use a solver to solve this linear programming optimization problem. Okay. So I will just increase font size. Okay. So the instructions, you can also get the data here. Okay. There are 2 departments, fabrication department and the finishing department. So fabrication department has 12 workers. Each worker works 7 hours a day. So based on this sentence, what can you say about total hours for fabrication? So quick cell F10 cutting equal 12 multiplied by 7. Okay. Next, let's see the finishing hours. Finishing department have 3 workers, work 7 hours. So for finishing department, quick cell F11 type in 3 multiplied by 7. And for marketing mixed, where is that information? Okay, you have this one here. -2 times number of Jordana plus decreased greater or equal to 0. Okay, I will change this to, remember in inequality in mathematics, both side you multiply by -1, so it becomes 2 times Jordana minus 1 times decreased, smaller equal to 0. I will change to that so that it will be consistent with this smaller equal sign here. Okay, so I will type in marketing mix, I'll type in 2 and then -1, and I will change this to smaller equal to 0. Okay? to be consistent with this, so that when I use the solver, I just want to add one condition, apply 3 situations. Okay. Now, look at this number here. Each pair of jadala requires 3.5 hours in fabrication and 1 hour in finishing department. So you should type in 3.5 in cell B10 and 1 in cell B11. And the next one, D-class requires 4 hours in fabrication and 1.5 hours in finishing. So you type in cell C10, 4, then C11, 1.5. Any questions? And also we have the profit. When you sell 1 unit of jadala, you make $50. When you sell 1 unit D-class, you make $65. So I am going to type in those two numbers maybe here, 50 and then 65. Any questions? We are just steps away to find the optimal solutions. Make sure you enter the correct data in the correct location. By the way, there are many different ways to solving this problem. What I will do, use the simple way. For example, I have consistent smaller equal than. I do not need to enter 3 conditions. I will just enter 1 condition, apply 3 situations. You could add 3 separate conditions. Okay, so watch out. And also when I use the sum product, I will just use 1 sum product and apply 4 times by using the fair handle. Okay, you could do 4 separate sum product. Okay, you go ahead, but I want to save time, to do it more efficiently. So what I am going to do, I will move this one actually to I will move this one to maybe copy Control-C and Control-V. I need this position to type in the objective function. Okay. So please move LHS, represent left-hand side above here. Leave this blank so that I will type in sum product function here. So equal sum product, opening bracket, quick cell B5, C5. Those represent number of units I will produce for each product. Because this number of units will apply to all the situations. So I am going to use the fixed cell reference by press F4 button. So F4 button, make sure it is absolute cell reference. $B, $5, column, $C, $5. Make sure it is absolute cell reference. The reason is I am going to copy down the formula, use the fair handle. Okay? So enter key. Now use the fair handle to drag it down. Okay, use fair handle to drag it down. And this cell is my objective function. Using the yellow background, I want to maximum this cell under condition all this number will be, oops, I will undo it. I messed it. I'll double check some product. No, I accidentally clicked something, so I'm going to retype in some product. F4 button. And then this cell. And then redrag it down. Okay? Any questions so far? All right. Now we are going to use solver. Quick data and the menu bar, then solver. In this dialog box, objective cell in my case, it is D9. Objective cell represents profit. So I want to maximum profit by changing cell B5, C5. I will delete the conditions because it comes from the previous example. Anyway, make sure objective function is D9 by changing variable B5 to C5, and then subject to constraint, click Add button. Now watch out, you click 3 cells together from D10 to D12, D10 to D12, smaller equal to, then click cell F10, F12, click OK button. Okay, can you hold on? Okay. Click OK button. And also make sure you select simple LP and click solve. You can get answer report, sensitivity report, limit report. Click OK button. And remember, during the lecture, we also covered this problem. You get the optimal solution. How many units you should produce for each model. Okay. Any questions? Okay. By the way, this example is also available on the textbook. During your lecture, I believe your professor also covered this one. Okay. So that is question 1. Okay. We set up the linear model and we use solver to solve the problem. Okay. Remember, you also need to know what is the answer report. There are some terminology here. Okay. What is the slang? Why we have 23.625 slang? Because our left-hand side here, we have 24. The maximum hours for fabrication department, 84, but we just used 60.375. There are some hours available, 23 hours available. Okay. And also for the sensitivity report, you have some terminology. What is the reduced cost? Okay. And what is the shadow price? Shadow price means when you change 1 unit, on the right-hand side, what happened to your objective function? Okay. Finally, it is the limit report. So this is question 1. And part 2. Suppose this company decides to change the price for decrease model. The new price will be $75. Okay. In sheet 2, set up the model and solve it. That is the question. So go back to sheet 2. This is the sheet 2. See here. Remember, I suggest change this negative number to positive number. This 1 to negative 1. And change greater equal to smaller equal to 0 to be consistent. Okay. And now the profit is 75, so you change to 75. And also I I want to copy these two numbers here because I want to use the sum product just once and then use the field handle. In case you didn't follow my first example, you can still catch up here. We do it all over again. If you have questions, we do it all over again. Okay, make sure you keep up with this one. We haven't done anything yet, just rearrange data and also move this L left-hand side above, move this above. Now we repeat ourselves. We use the sum product formula, and then we use the solver to solve it. That's it, okay? So, quick cell D9. This is my objective function, D9. Starting equals sum product. Opening bracket. Quick cell B5, C5, F4 button, comma, and then quick cell B9, C9, closing bracket, sum product. After that, you use the field handle to drag it down. Field handle, drag it down. Oh yes, I did use the absolute cell reference. Make sure you use absolute cell reference for B5, C5. Now we are going to data solver. Objective function, that is D9. D9 is objective function to maximum by changing the cell range B5, C5. Okay, I'll just delete the constraints. I want to make sure the constraint from fresh start. Now click Add button. Delete the existing constraints. Delete the constraints. Then click Add. Cell reference. D10 to D13, smaller equal to constraints, select F10 to F13. I select 3 cells together. Okay, I select all left-hand side, smaller equal to right-hand side. Okay. Click OK button. Okay, and make sure variable in non-negative, simple LP, quick solve, answer report, sensitivity report, limit report, click OK button. So this is the number you get. Okay, if you change the profit, the optimal solution has been changed, and also the profit has been changed. So this is the question B. Okay. Now questions part 3. Part 3. One of the interns has decided it would be much better just to focus on market mix and remove the finishing and the fabrication constraints. Remove the constraints to solve the model. Okay. This time we are going to use worksheet 3. So go back to worksheet 3. Linker schemes, worksheet 3. And in this worksheet, we do not have constraints for fabrication and finishing. We only have constraints for marketing mix. That's it. That's it. Okay, let's solve this problem. Okay. Let me see. So quick cell, let's increase the font size first. Quick cell D7, typing equals sum product. Select cell B5, C5, F4 to change to absolute cell reference. And then select B7, C7, closing bracket. So this is the objective function. And we only have one constraint for marketing mix. So I quick cell D12, typing equals sum product. Quick cell B5, C5. This time I don't need cell reference, absolute cell reference, because I do not need to copy down the formula. So, okay, just select the cell range, sum product. Click enter button. So we have one objective function and one constraint. That's it. You want to see the formula. I just type in two formulas. This is the formula I type in. Okay, I just type in those two sum product. And now let's use the solver to solve this problem. So I will click data solver. Set objective D7. D7 is my objective to maximum by changing cell B5, C5. Okay. I will delete all the constraints, then re-add the constraints. Delete and delete. The constraints, I just have one. So I click add button. That is the market mix. So quick cell D12 greater or equal to 0 or F12. D12 greater or equal to F12. Then click OK button. Okay. Simple linear LP and click solve. Now you have the problem. Objective cell do not converge because you do not have the constraints for the fabrication department and for the finishing department. So it is impossible to solve this problem because you do not have constraints. Okay? So this is part 3. Okay? And part D. Somebody by mistake has used greater or equal sign for fabrication constraints. Found out what result you are going to get if you change smaller equal to greater equal for fabrication constraint. So that is in worksheet 4. So we click OK first for this one. Worksheet 4. So the question said, by mistake, you changed the greater sign for fabrication department. So you change this one. Before it is smaller equal. Now you change to greater equal. Now let's see what happens. Okay. Because we have different signs here, so I'm going to have 3 different sum product functions. Okay, 3 different sum product functions. So let's do the objective function first. Quick cell D7, typing equals sum product. Opening bracket, B5, C5, comma, then B7, C7. Next, create cell D10 typing equals some product B5, C5. This time I want to use absolute cell reference, so I press F4 button. And then B10, C10, closing bracket. Because I used absolute cell reference, so I can copy down the formula. Use fill handle. You could use 3 different sum products for each cell. So after that, I will use the solver, add those 3 constraints. So click data and the menu bar, solver. Objective function D7 to maximum. By changing cell B5, C5, again, I will delete all the existing constraints. Then add new constraints. Click add button. This time I need to add 3 constraints. One is left hand side, D10 greater equal to F10. D10 greater equal to F10. Then click add button. D11 smaller equal to F11. D11 smaller equal to F11. D11 smaller equal to F11. Add button. Last one, D13 greater equal to F13. D13 should be D13, okay? D13 greater equal to F13. Click add button. Then click OK button. Okay. Click cancel. So anyway, you have 3 constraints here. 10, 11, 12. No, should be 12. The last one I have to D12 greater equal to F12. D12 greater equal to F12. So double check the constraints here. Oops. 10, 11, 12. And then when you click solve button, you come up with this result. Looks like I have to double check. So that is the question 1. Next, we are going to do question 2. In this question, you have 2 brands, and you have 3 ingredients, A, B, C. Okay, 2 different brands. The question asks you how many pounds of each brand should be purchased. That is the question. So go to the Excel, go to the HM Turkey worksheet. And we have to punch in some numbers. A, B, C. I'll try to copy this number. See, this number I'll just copy and paste into Excel. Control C, and then Control V. Okay, I just copy and Control C and Control V. And then I also need this one here, these three numbers. Control C, and then Control V. I just copy and paste from Word document to Excel. Alright, so the question is, how much of each brand should we buy? Okay. And what is the cost contribution? It's here, 2 cents and 3 cents. So you type in 2 here and 3 here. Now let's type in the objective function in D7. Type equal sum product. Opening bracket, B5, C5, comma, then B7, C7, closing bracket. I do not use fixed absolute cell reference because I do not copy this formula. So it's just B5, C5, B7, C7. Next, I will use absolute cell reference in D10 because I want to copy down the formula. So type in equal sum product. B5, C5, then F4 button. After that, B10, C10, closing bracket. Now copy down the formula. We are ready to use the solver. So data solver. Quick reset button. Reset all. Because this is a brand new problem, you quick reset all. And then set objective. Quick cell D7 to minimum because this is the cost. We want to minimum the cost. This is the cost. We want to minimum the cost, okay? By changing variable cell B5, B4, C4. Subject to constraint, quick add button. Select D10, D12, 3 cells together, D10, D12, because they all have greater equal sign. And then select F10 to F12. Click OK button. Okay. Make sure it's simple LP. Click solve. Okay. And click OK button. What did we get? What something happens here? So that is the procedure, okay, for the linear programming. In summary, what we did today, we just did one problem, how to use Excel solver to solve optimal problem questions. We want to maximum profit and minimum the cost. The question is how much of each product we should produce, okay?